about first round. So fractional calculus and what and why, you have seen this one in the beginning slide, so I'm not going to repeat. And so why we need to talk about it and what it is. So these two bullets will be enough, okay? And so now I'm going to talk about how these things can be combined together and have some synergy into it. So to talk about this, we need to understand that there is an international journal called Mechatronics. Its impact factor is 1.25. And editor-in-chief, not very clear from your point, is a European, yeah, it's called, it's a Stenbuch, okay, Stenbuch. Yeah, Professor Stenbuch. I'm one of the editorial members. So we proposed to do a special issue on this one. We started early last year regarding fractional auto modeling and controlling mechatronics applications. And the guest edited by these people, and Clara and Dr. Ricardo Carbonato and myself. So to my good surprise, we received about 30 submissions, okay, for that special issue. And so the purpose of the issue is basically to try to see that the applications in mechanics, electronics, computing, control engineering, you see those circles, so in different areas. So hopefully in the end we have a simpler, more economic, reliable, and more general purpose system. So make your products more competitive, okay? So that's the purpose by using fractional calculus. So I'm going to just to show you that those accepted paper titles give you a flash, your feeling about. Did I time myself? Oh, I haven't started. Sorry. All right. So you can see I gave you a rough. So these are the authors and titles. All the tuning of PID control according to fractional order reference model, approximation for DC rotor control. Creep modeling, identification of piezo actuator based on fractional order systems. Piezo, lots of hysteresis there. Okay, memory, you know. And so people are already talking about this. Okay. And talking about the variability of fluctuations in the delay over the internet. So this actually I motivated this work quite a while ago, and still having good consequences. Still people working on this. And FPGA implementation is also interesting. This is on the PM, permanent magnet synchronous motor velocity servo. So you can see lots of motion control servo. And this is a reset control using fractional order reset control, using as a servo motor. Our friend Wallace Vinegar's group's paper. So all these are published already online. You can download the PDF if you want to read. And also, so some groups I don't really know, like fatigue. So if you say, oh, yeah, I'm tired, basically it's a fractional calculus, so going on. That kind of process is fractional order. So they do a fractional order control for those electro-hydraulic system. I know that Purdue has a very strong hydraulic power system. Fractional model of dynamic backlash. This is also backlash has memory, remember? It's like hysteresis. And our common friend, Machado, did some work on this. I haven't read it. And so, our friend Dimitro Bariano is still doing chaotic system and using sliding motor control, doing synchronization. And this is a piece of work my student did on the heat transfer problem. And we introduced a fractional pole into the model so that it can characterize the dynamics much better. So it's very interesting too. So you can download a copy if you have interest. Here's another piece of work regarding, again, chaotic fractional order using state feedback. And this probably is even more interesting about stochastic fractional order system using a generalized common filtering. So, And the last one, we did disturbance observer design using Bodhi's ideal cutoff filter in the disk drive server. We implement that one in the real product. So, future perspectives. So I just flashed to you that there is connection about mechatronics and fractional calculus. They met already. There is a dedicated special issues coming out. There are more papers in the pipeline, but I don't want to show you them. It's not very nice. It's not put online yet. I'm handling some papers, and we split the load. So those not online published, I'm not going to show you, but it's a long list, like 30 papers, okay? In different aspects of mechatronics. But majority of them are focused on motion controls, okay? Servo mechanisms. So, but I think from my perspective, like I like George's comment yesterday regarding control people should dare to attack more challenging problems. Okay? Just do a DC motor, then what? It's too simple, you know? Don't do it. So in Chinese, like, why you kill a chicken using a knife used to kill the cow, you know, kind of thing like that. And so you don't want to overkill the problem. DC motors control is simple, too simple. So what is not so simple? Say, for example, biomechatronics. Okay? So you have a skeleton and enhance yourself. How do you optimize the design of the skeleton? Exoskeleton for yourself. So when I get very, very old, I can move myself and I have my exoskeleton to help myself move around. So how do you best design it? How to control it? That probably you need fractional order mechanics and fractional order controls modeling. And nanomechatronics, okay? And optomechatronics, and human-centric mechatronics. So you put human as the center. So all these things is more challenging because you involve human in a loop. And human is a complex system. There must be, it has lots of variability or fluctuation, sometimes frustration. So all those things, you need new tools, okay? Like Chris already showed you that. All those variabilities, all those fluctuations, then if you check it detailed way, you'll see that is inverse power law, and behind that, there's a fractional dynamics going on, and stuff like that. So a piece of information here, this August, first week of August, I organized a panel discussion session there. It's a similar title, it's Mechatronics Meets Fractional Calculus. At that time, probably I have more papers I can show, accepted papers, and the future directions. I want to make the slides here more detailed way. And so it is in Orlando, so Portland, Oregon, okay, Portland, Oregon. We're going to be there and having my panelists. These are my confirmed the panelists of future directions. I'm going to write a summary about what the panel said, and so give a report, put online to share with the community. So just another piece of information, and we just came back. The reason we have the luck to have Professor Amparuni, Professor Menardi here is because of an event happened in, you cannot see, in Rhode Island, organized by the Applied Maths Department of Brown University on fractional PDE conference, symposium. I gave a talk on this, saying more optimal image processing by fractional order differentiation and fractional order partial differential equations. Lots of interesting. So I'm putting here first slide and the last slide. So last slide I gave a take-home message. So basically I said this way, and later on I added this one in case people didn't get it. What's that? Saying it's very simple. You plan worse. So you did something in an optimal way. You're very happy, and So now people challenge you, can you be more optimal? Can you? You say, I'm already optimal. Can you be more optimal? You know? Then you say, I don't know. Because I don't know fractional calculus. So my point is, want to be more optimal? Then go fractional calculus. That's my message in this talk. So we add lots of tweakings, add lots of fractional differentiations, different image processing. So we show that there's an additional tuning knob you can achieve more optimal or better than the best results in terms of image processing. There are 5 aspects like edge detection, enhancement, denoising, segmentation, and optical flow. And good news, these slides are all posted online right now. Eagle, right?
Yeah.
Yeah, but Bruce West one is not there.
With some exceptions from local people from now.
So actually it's already online. And so before I switch to my next talk, I have another 10 minutes. So I want to show this blackboard again. I think we really need to sometimes to have a very stimulating discussions like this. Will have a long-lasting effect. It's a power decay, you know, to your mind. You know, sometimes I saw this whiteboard. I feel, wow. Actually, we realized that mechanism that long time ago. We just didn't focus very well. And now we look back, we feel over the years we gain deeper and deeper understanding about fractional dynamics and the consequences of fractional calculus. Okay, so thank you for your attention. I'm going to switch to another. So let me see. I promise. Okay, so we are here. I just finished the mechatronics meets fractional calculus. And of course, unmanned air vehicles, mobile robots are special cases of mechatronics. So I don't have to talk about UAVs and mechatronics, and UAVs and fractional calculus. So we can find a separate time to talk about it. And so next, any questions at this point? Okay, so I hope I can give you some of the stimulation here. Next, I'm going to talk about next one called ME280, fractional order mechanics. And thank you, Chris, to put the fractional order mechanics on your slides twice. I counted. Thank you for advertising for my course. So I told you I cannot be more happier having a job here. And I feel like in UC Merced, I pay the same effort, may have a bigger impact in terms of educational and research activities than the situation I had in Utah. So that's my perception. I feel very happy. And additionally, I feel very happy I only have 2 real courses to teach every year. One is mechatronics to inspire the juniors. Okay, juniors. And another course I'm going to teach is this ME 280, okay, called fractional order mechanics. I created it, recreated it, okay. It was called variable order mechanics, coined by Coimbra, and who quit the university to UC San Diego. I tried to bring him here, and he cannot make it. He's in the quarters final exam. And by the way, I also contacted Jerry Spanian. He's a UCI. He said I'm 80 something, and I cannot really travel. Fully committed in summer. He said hi to everybody. So sorry I cannot be here this time. So I said next time I bring to his house and to have a fractional calculus day. I was joking. I also tried to bring Oldham here and send him email. So do you have a plan to visit the United States, and I can host your stay in California. Because I'm too old to travel and I don't have a plan. So I tried to bring Old Hang and Spaniard both here, and it was successful. And so I'm going to go quickly about the fractional order mechanics of the course I'm going to teach this fall. Okay. And again, and if you are, so I'm going to pass the syllabus. Okay, this is a colored copy syllabus here. If you want to keep one, you keep one. If you don't, just pass it over. And this is the course flyer. Okay. So I'm going to make this posted on the campus. But I only have 10 slots. I only accept 10 students in the class. My ambition is to make everybody's term paper published in.
Selected people.
Published in a good journal. They're in their area. Or I can try to do some special issue. But anyway, here is the talk. This is actually a talk I gave in last October. At that time, I determined I want to do this. But I need to convince myself and my students in my lab first. So I gave this presentation to them. So I'm going to go over this set of slides, then we can finish. And I said 5:40. Okay. So I have 7 minutes. All right. Okay. So this is a standard 3-minute advertisement like in YouTube. We can skip that. So no, we can skip that. So we can skip that. So here is the one. I hope today you remember that. You may say that, oh, I heard a lot of fractional calculus stuff. That's very interesting. But in the real world, in my field, I don't know when I should talk about it. Okay, whenever you see these, you should immediately think about the connection to fractional calculus. So I call this is fractional order thinking. Okay, fractional order thinking. So like fluctuations, that is exactly presented by Chris Carroll regarding the noise. Okay, noise and power law, scale free, and so on and so forth. Like the soft matter, like shear thickening, those liquids, I think is considered as anomalous liquid. Anyway, why we need to talk about fractional order mechanics? Because everything we face is soft inherently. If you claim something that is hard, it's always relatively hard. But it's absolutely soft, okay? So from that perspective, okay, soft materials are all around us and even assemble our body. So then what we learn from textbook is all highly abstracted, idealized. Rigid body, hard matter, and its lump parameter, and so on and so forth. But in real world, you don't. You have granular, particulate, porous, disordered materials. Okay? Especially our 3D printing right now. Okay? You have a laser sintering process. You move the dots, you get a line. You move the lines, you got plane. You move the plane, you got 3D. And you can do a lot of things. Okay? So in that sense, it's more interesting to talk about fractional order mechanics. Okay? There's a need. So we probably should, in the long period of time to come, we need to talk about mesoscopic system behavior. Okay? So living in the micro level or nano level, micro level, probably will not be enough. We need also talk about mesoscopic. So these are softer matters. So this thing you have already heard enough, the interpolation between them, and interpolation, okay, between the operators. So it's pretty natural. This is, to me, fractional order mechanics. Okay? So it's pretty natural. In the end of the day, you probably are being convinced already, okay? There's a person saying that there's nothing so practical as a good theory, so my submission is using integer order calculus is never been the best, okay?
I'd like to add a sentence of Einstein, something like that. There is nothing of applicable than a good theory. I suppose was Einstein. There is nothing more applicable than a good theory.
Then a good theory?
Yeah, like this.
Yeah, yeah. There is nothing so practical as
a good theory.
Good theory.
Yeah, I got a similar sentence from Einstein.
Einstein. Oh, I don't know.
Yeah.
This is cited from a book in here, and I didn't read the book, I haven't checked that. So I saw a quote on this.
Oh, probably are independent from
This
it.
quote is accurate, but Professor Maynard speaks about similar.
Einstein said the similar thing. Okay, great.
Okay.
Yeah. So I think all the great minds are similar. If they are not similar, then we're in trouble.
Anomalous is normal.
So I did what Google says about fractional order mechanics. I did something here, and we can later on. Again, this is I copied from Eagle's slide, and we may express our.
I copied it from Scott Blair.
Express our concepts in a Newtonian term if we find this convenient. But if we do so, we must realize that we have made a translation into language that is foreign to the system which we are studying, which means we are using integer order calculus to model everything here, and it's fine, nothing wrong, but be careful, it's only for our own convenience, okay? The nature is not running that way. The nature is running fractional order way. That's the message, okay? So, fractional order mechanics, what we should include this course? It was variable order mechanics is too narrow, so I believe we need to define what is fractional order mechanics. So if you put a fractional order derivative into the model of mechanics, will that be good enough? So I made some suggestions about what should be in this fractional order mechanics at that time. I'm still using it, so you can check my syllabus. So I want to cover some basics and also fractional order signals and systems, Laplace transform, Fourier transform, some basic modeling like Eagle today presenting metaclassical function fitting, and translate that fitting into fractional order differential equation to review some of the background fractional order dynamics of evolution. Then I'm going to cover those Bagley orbic mechanics to introduce fractional order damping into second order rigid body dynamics into that. So that's should be covered. Another thing, I'm not really expert on that, is Euler-Lagrange equation in a fractional order way, using a fractional order calculus of variation. So that one will be a module. So I'm going to leverage from Agrawal. So that's what I'm going to learn in Portland from them. I also organized a one-day tutorial from Then will be advanced topics for each student, 10 students. Everybody will focus on the area of their PhD study, then give a very focused study and detailed report. So there are many possible topics. When they focus, I give some suggestions and mentoring. Hopefully they have something really come out from the course study that is publishable. Publishable means at their field, the top tier journal, okay? That's my ambition, we'll see. So that's why I only need 10 students, okay? So if during the semester, if you come over and wants to give me a guest lecture, that will be fantastic. I'll arrange you in. I'll see if I can invite my colleagues in the campus, like Chris Carroll. You can give us scaling law talk again, guest lecture one time. So we'll see. I'll try to organize. So basically, this is ME 280. I think it's officially approved. They said May 28th. And so I don't know. So again, so why we need to, when we should talk about the fractional order mechanics, again, whenever you see this, you should immediately think about its connection to. So I'm done. Thank you for the long day. I'm very happy you are here, and we can do this 2 years later, and 2000, if I remember correctly, it's 15. Okay. Hopefully I'll see some of you still around. You have any?
I have a little addition.
Yeah.
Actually, with your help, in 2007, I had, I think, the first course of fractional
Yes.
differential equations and applications in engineering. It was at Utah State.
Yeah, yes. Yeah, that course is also still online.
ECE 6930 latest.
Yeah.
And it is still online.
Yeah, still online. That's excellent also.
And then did you sure also
Did a summer
enhance it,
teaching.
improved it in 2009?
9, yes.
So all those efforts also are due to Yangquan Chen. Introducing this stuff into real education is nice. And also, I had not a large group at that time, but all those students used fractional calculus in their PhD research.
Well, more or less, yeah. In Utah right now.
Yeah, yeah.
And there's another news regarding Ivo Polugni. He's a PI of a project one for creating an online course for fractional calculus for everybody. And so you know that the Stanford professor created online Sebastian Thrun doing artificial intelligence, machine learning. Okay, yeah. So I envision, okay, when I retire, I don't even need my pension. I just need this course.
We'll see.
The cash will flow. The people need it. Everybody needs fractional calculus. You know, they just do online and subscribe.
I think we should moderate ourselves sometimes. Yeah. I think fractional calculus is really a good tool now for better modeling. Definitely. Nature simply exists. Nature is not of integer order, is not of fractional order. Our models can be of integer or fractional or
Excellent.
whatever else.
Thank you. So, see you, okay.
Quick question. You had mentioned several times that the transport of the part of material that might be good example to use fractional order.
Yes. Yes.
So for you, I know you have a lot of paper and other books. Do you have a specific chapter about?
Yes, there are many. I'll show you.
Okay.
Can I make a comment?
Okay, go ahead.
No, probably from a mathematical point of view. You know, in principle, any differential equation of integer order can be generalized into fractional order. Okay, so that we can make infinite papers, infinite. But as a physicist, I have to distinguish two kinds of equations.
Yeah.
The constitutive equation and the physics law.
Yeah, that's a
For
good
example,
point.
the conservation law is a physical law. Second principle thermodynamics is a physical law that we cannot change. Instead, we can change, fractionalize every constitutive law. Of course, this the first example, in my opinion, okay, according as far as I know, of application of functional calculus was in viscoelasticity. Starting from also software, of course, was one as a pioneer, but also before, because the stress-strain relation is not a physical law, depends on the material. But no, just to say that we have to be moderate to fractionalize everything.
Okay.
One thing is a model of a constructive law, and instead there are examples of people who generalize quantum mechanics. Seems to me is not the case, at least, if you don't have any physical.
Right.
But anyway,
Thank
just
you.
to say that you cannot be too much optimistic.
Okay. Thank you, Francesco, for the remark, and advice to everybody: don't do anything non-physical. So that reminds me of a comment made by Rudolf Kalman. You know, Kalman filtering. In 2005 IFAC World Congress keynote speech, he said, "Put physics right. The rest is mathematics." I love that. So,
But nevertheless,
not vice versa.
but vice versa, you can make physics with good mathematics.
Excellent. So thank you for coming, and I'll see you around all in 2015.
Thank you very much for making this.
I'm very happy to have you here. And okay. All right. So we are going to leave here soon. Oh yeah, we have 10 minutes grace period. Yeah, thank you. No problem.
It was nice meeting you. I need to go.
So we will not meet. You miss dinner.
I'm going to miss dinner. I don't know how long are you around. Oh, okay.
Just a few words.
Okay.
Oh, my